Okay, hello there. So today we're going to take a look on how to predict redox reactions. And when we're predicting redox reactions, what we want to understand is that even within a reaction, you can have more than one OA and RA. So this is telling us exactly what's reacting if there's more than one present. So here, just going over a few things, if you have a solution right here, so if you have a solution, that means you have water present, and water is an OA and an RA. You can find it on both sides of the table. If you have a potassium permanganate solution, that means potassium and permanganate ions are both present. So we'll write that down. And potassium is an OA. Permanganate does not occur by itself, but it's good that it says acidic here, because anything that is acidic will have hydrogen present, the ion. So together, this is an OA. Hydrogen alone is an OA. And then we've already accounted for solution by saying water, so we don't have to do that again. But you also have tin 2 chloride. So tin 2 and the chlorine ion. So tin is on both sides of the table, and the chlorine ion alone is an RA. Chlorine also occurs with water as an RA, but it's really weak, so we can ignore that one for now. And then when you're listed everything that's there, your next step is to pick the strongest OA and the strongest RA. So permanganate with hydrogen is the strongest. If you take a look at a reduction half reaction table, it will be near the top. And then we're going to look at the RAs, and your strongest RA, I believe, is going to be tin 2 positive. I just want to double check. Yeah, it is going to be tin 2 positive. So looking on the right hand side of the table, starting at the bottom and going up till you see your first RA. So those are our half reactions. So for the reduction reaction, you can write that down from the table exactly how you see it. So MnO4 negative plus 8 hydrogens. So I'm not doing anything here but copying down the half reaction from the data booklet. And that will give us our products plus 4 water molecules. Then I want to write down my oxidation reaction. So if you're looking at the reduction half reaction table, you're going to have to flip this reaction. So I'll have SN2 positive as a reactant, giving me SN4 positive plus 2 electrons. Okay. Now that I have my 2 half reactions, I can add this together once I've balanced my electrons. So I'm going to multiply the bottom reaction by 5 and the top reaction by 2 to make a total of 10. Now with adding this together, I'm going to start to write down all of my reactants. And I'm bringing the 2 through, out everything within. Plus 10 electrons. And now I'm done with my reactants for the first reaction, so I'll look at the second, and I have 5 SN2 positive. And same idea, I need to multiply that 5 throughout. And now I can look at my products and doing the same thing, continuing. I have 2 Mn2 positive plus 8 water molecules plus 5 tin 4 plus 10 electrons. Now, before I finish off this reaction, you do want to simplify it. So anything you see on both sides as a reactant and a product that is exactly the same can cancel out. So our electrons should definitely cancel. And sometimes you might have hydrogens or waters reducing as well, but not in this case. And then lastly, you want to predict if this reaction is spontaneous or non-spontaneous. If you look at your table, your OA is higher up than your RA, so this would be a spontaneous reaction. I hope this was helpful. Please let me know in the comments if you'd like me to do any other type of problem. Thanks.